So it's more example for solvable for y. Why we say it's a solvable for y problem? Because y is some function of x and p. So that's why we use solvable for y method. The first step of this method is differentiating both sides uh, with respect to x. The left hand side y becomes dy dx 2px when we differentiate 2px, when differentiate x to p here 2p, and when we differentiate p it's become dp dx. X square differentiation is 2x p to the power 4. When we differentiate p to the power 4 it's become 4pq dp dx, and x square is unchanged. Again we repeat the term where dp dx is, just to consider all the term which consists dp dx. So here we write all the term considering dp dx. We just take common dp dx, as well as some quantity may be common, may not be common. In that particular case there is a common term is 2x, and the remaining should consider the another part. Here we can observe 2pqx plus of 1 is a common factor, so here we write this one, and this one is the another factor. When we consider this one equals to 0, we defined it, we can solve this problem dp by p and dx by x, and integrating both sides 2 log p. When we integrate both sides, this one 2 log p plus log x equals to log c, and this becomes log p square, this becomes log x, so the result becomes log p square x equals to c. So p square becomes c by x. P should be root over of c by x. Therefore the general solution, if we put the value of p in equation 1, we get the general solution of this equation. Here it is 2px plus p to the power 4x square. When we put the value of p is this, in that case the result becomes exactly, the general solution becomes this, where we put the value of p, here we put the value of p to the power 4x square, should cancel out, so the result becomes this one. So the result becomes exactly, the result becomes this. Okay, exactly the result becomes this. So here we consider another example. How can I consider this example? 1 minus p square sine inverse px minus of y. Then how can I say this problem move to solvable for y? First we write px minus of y is sine of 1 minus of p square, and y is px minus of 1 sine 1 minus of p square. Therefore it's clearly, you can write the right hand side in terms of p and x. Therefore it's a solvable for y model. Just to take the differentiation with respect to x, it's become dy dx. When you differentiate x, this becomes 1, so it's on p, so this one should be p, and the remaining quantity is x dp dx. When you differentiate sine 1 minus of p square, it's become cos 1 minus of p square. 1 minus of p square differentiation is minus 2p dp dx. Here it makes a calculation. So when we input dy dx equals to p, this one should cancel out, this one should cancel out from both the side, and the remaining quantity becomes this one, exactly this one, okay. That should be the remaining quantity. Here we consider two different cases. One is the dp dx equals to 0, another one is this dp dx equals to 0. P is constant, then we find the general solution y equals to cx minus of 1 by c square. This one is another example. For your better understanding, we give another example solvable for y. This one is another example for solvable for y. This you can write this one, y is 3x plus log p, differentiating both sides with respect to x. The left hand side becomes dy dx is p, differentiation of 3x, it's become 3, and this one is 1 by p dp dx in the left hand side, and the remaining quantity on the left hand side, and dp dx in the right hand side. So the result, when we integrate both sides, the result becomes exactly this one. So 3 to the power 3x 1 minus 3 and p becomes this. When we substitute this result p in equation 1, we get the general solution. The question is that, is this problem, can I solve this problem? The question is that, can I solve this problem in any other method? Yes, you can solve this problem in other method also. So here we give another procedure. If you do not write this one is solvable for y, you can also write this one is solvable for x also. You can also write this one is x equals to y minus log p log p. You can write this one log p. When we divide by 3, this becomes y by 3 and this becomes log p by 3. The procedure of solving of a differential equation first order higher degree solvable for x. That means this problem also can use solvable for x. In that case, first we take the differentiation with respect to y. It's become dx. It's become dy dx dy, that is equals to, this becomes 1 by 3, this becomes 1 by 3 minus, this becomes 1 by 3 into 1 by p 1 by p 1 by p into dp dx dp dx dp dx. Okay, so just to consider this one, this will come next. The next step we write, if you can remember, we can write this one is 1 by p 1 by p equals to 1 by 3 1 by 3 minus 1 by 3p dp dx dp dx. So the next step is, you just consider 1/3, 1 by p is in the right hand side and this quantity in the left hand side. Therefore the result becomes just consider this result. Therefore the result becomes 1 by 3p 1 by 3p by 3p equals to 1 by 3p dp dx 1 by 3p dp dx 1 by 3p dp dx, that is equals to 1 by 3 minus 1 by p. So the ultimate result becomes dp dx equals to p minus 3. The result should be p minus of 3. Next step is, how can I write the next part of this problem? How can I write the next part of this problem? So the next part becomes, when you consider next part here, the result becomes dp by p minus 3 minus 3 equals to dx. So integrating both sides, if we consider the integration both sides, in that case here we consider the arbitrary constant c. So the result becomes x equals to log p minus of 3, log p minus of 3 log p minus of 3, this one becomes log p minus 3 plus c. If we put this result of x, if we put, here I give a very big mistake here. That should not be x, that should be y, that should be y, that should be y, that should be y, that should be y. So this one becomes y, and integration of this, the result should be y equals to log p minus 3 plus c. If we put this result in that equation, if we consider this one is your equation number 1, this one is your equation number 1, and this one is your equation number 2, this one is your equation number 2. In that case, if we put this value of y here, we can find x in terms of p and c and y in terms of p and c. That should be the parametric representation of the required curve where the differential equation is given. Thank you for listening.